Hey guys, so today we're going to talk about points on a terminal side / the unit circle. So let's get right into it. So the first thing that we need to talk about is this wonderful unit circle that we have here. So the unit circle is kind of defined by three important things. So here we have our degrees. So this is our degrees. So as we go around the circle, we have 0 degrees, 30 degrees, so on, and we have 180 all the way here, and then we go all the way around to 360. So make note of that, okay? Then our next part is going to be the radians, and this is denoted usually by pi, but at 0 it's just 0. So if we looked at our next one, it's pi over 6, and then we have pi over 4 and all of that. So mark this as our radians. Okay? So again, you have pi over 6, pi over 4, pi over 2, all the way around to pi, and then it gets a little bit more complicated as we go down, and then we get to 2 pi. Okay? So then lastly, we have the points on the terminal side, and that is going to be what you think it probably is, and this is this last thing. So it's on the outside of the unit circle, and it's in a coordinate form. So at 0, it's 1, 0. Now, you're probably wondering, Miss Smith, I don't get why they have these coordinates. So say, for example, we had a circle with a radius of 1, and equals 1. So this is that point at the very edge of that circle. And then at these 4 points, if you notice, they have nice little coordinates. So at the very tippy top, it's 0, 1. On the way left, it's -1, 0. The bottom, 0, -1. So those are those 4 nice points. Well, in order to make a circle, we need a little bit more points than that. So that's where the root 3 over 2, and then 1/2, and then our next one and another one, so that it makes a little bit more of an even circle, more than just a polygon, if we were just to connect those 4 dots. Okay? So let's move on. So what is a point on a terminal side? So let's say I was given the angle 135. So I start at my 0 and then go to angle 135, and as I've said before, my initial side starts at 0, and then my terminal side is where it ends. So initial and the terminal is where it ends. So when I go to the terminal side at 135, going to my unit circle, so I'm going to go to 135. My terminal side is 135, and I have a coordinate associated with it. And the coordinate is negative square root of 2 over 2, positive square root of 2 over 2. And that's where the point on a terminal side comes from. Okay? So now let's use this in practice. So say I was asked to find the cosine of 270. Well, cosine, you've probably heard of it before. It's those little squiggly waves, and we use them in circles. So if we have the cosine of 270, well, we're going to go back up here, and we're going to go to 270. So let's start with that. So looking for 270, and we find 270 right here. Now the next part to this is the cosine. Now a very important note that you need to make, and that you will need to remember for the rest of this unit, is that our coordinates are set up as cosine and sine. Okay? So the cosine of 270, if we look at it, is going to be our x-coordinate. So my x-coordinate is 0. So if I go to here and cosine of 270, I say, well, this is my x value of my coordinate. So the cosine of 270 is going to be 0. Now you're probably thinking, Miss Smith, that's kind of weird. Well, I can even show you with Desmos. So in Desmos, if I did the cosine of 270, and I have to make sure I'm in degrees for this, I will get 0. So I proved myself. Alright, so now let's move on. Now the rest of these should be okay. So we have our next example. We have sine. Well, remember it's cosine sine. So sine is my y value. So we need to find the y value of negative 120. Now you're probably thinking, as we go back to the unit circle, Miss Smith, there is no negative 120. Okay, well that means we just got to find the positive version. Okay, so negative 120 is just another way of saying instead of going counterclockwise, we're going clockwise. Now, instead of just trying to imagine it, we can find the positive version. So what we're going to do is just do 360 minus 120, and 360 minus 120 is 240. So instead of sine of negative 120, it's like we're doing the sine of positive 240, and it's still the y value. So let's go find that on our unit circle. So 240 is found right here, and our coordinate is here, and then we're looking for the y coordinate because we're doing sine. So our answer is negative square root of 3 over 2. So we have negative square root of 3 over 2. And I want the exact answers for these. I don't want that funky decimal that you would get if you put this into Desmos. I want the exact answer, meaning I want square root of 3 over 2. Nothing else. Alright. Alright, so now for the next example, I want you to try this one first on your own. Now you might be a little confused at first, and that's okay. You can continue on. But I first want you to pause the video here and try it on your own. So, if you tried this on your own, you figured out that you need to do 495 minus 360 because we don't have a 495 on our unit circle. So 495 minus 360 is 135. So here we're finding the cosine of 135, and we know that my cosine is my x value, so going to 135 on the unit circle, and then going to my coordinate, and we only need the x value, so my answer is negative square root of 2 over 2. And that would be it. Alright, so now we have this next part. We're going to be dealing with the radians. Okay, so it's going to be the same business, it's just going to be a little bit different. So, we have sine of pi over 4. So sine, just like before, this is my y value. And I don't have to alter pi over 4 in any way, so I'm going to go find it. So pi over 4 is found right here. And we're looking for sine, meaning our y value. So we have root 2 over 2. So sine of pi over 4 is root 2 over 2. Okay? So this next example, cosine of 2 pi over 3, I want you to try this one by yourself. If you need the unit circle, there is a link to it on Google Classroom, or you can just Google search it. Alright, so try this one on your own. Alright, so if you did this correctly, you should have gotten negative 1/2 as your answer. So all you had to do was go to the unit circle and find 2 pi over 3, find the x coordinate, and negative 1/2 was there for you. Alright, so then we have our last example. We have cosine of negative 17 pi over 3. Now, if you went to the unit circle and you looked for 17 pi over 3, you'd say, that does not exist, Ms. Smith. How is that even possible? This is where it gets a little bit complicated, but it'll be fun. So, say we have our unit circle. We're going to kind of make our own for a second. And we have 0 and pi, and then also 2 pi's at the same spot. Well, if you notice, we had pi over 3. And that's related to this guy. So we had pi over 3, and then from that last problem we had 2 pi over 3, and please excuse my terrible drawing skills. And then if you looked further, we had 4 pi over 3, and then we had 5 pi over 3. Now you're probably wondering, well, what about this one, Miss Smith? Well, this is another way of saying 3 pi over 3, but it was reduced. So, the one thing that's cool about the unit circle is that it continues on even though it stops at 360. So, for example, this is 0, so we're going to go 1, 1/3, 2/3, 3/3, 4/3, 5/3, and then 2 over pi is also known as 6/3. Well, I can keep going. So 7/3, 8/3, and then 9/3, 10/3, 11/3, and 12/3, and so on and so on. And it may take me a hot minute to get all the way to 17, but just counting, and I'm just going to write the numbers for this. So 12, 13, 14, 15, 16, 17, 18. Well, we hit 17, which was right here. So 17 pi over 3 is the same as 5 pi over 3. So there's one thing that we need to make clear about this as well, is that it was negative 17 pi over 3. So if this was a positive 17 pi over 3, we could stop here, find the cosine of 5 pi over 3, and we'd be set to go. But this is negative, so things are a little bit different. So since 17 pi is the same as 5 pi over 3, and I didn't mean to erase that, we're going to look at this in a backwards way. So the one cool thing about the unit circle is that if we have a negative and it ends up here, we can just reflect it over the diameter, and it's the same as the one that's up here. So 5/3, when it's negative and we land at 5 over 3, the positive version is on the flip side. So the positive version is pi over 3. Now I could do a whole new unit circle where I go backwards with 17 pi over 3, and I would still get to this part. It would still be the same as pi over 3. So pi over 3, if we go to our unit circle, is 1/2 and square root of 3 over 2, and we're looking for cosine, which is my x value. So my x value in this case is 1/2. So my answer for the cosine of negative 17 pi over 3 is 1/2. All right. Have an awesome day and stay safe.